Hello all, welcome to my channel Crystallized Science. So today we will discuss about mole concept, which I think is the most difficult concept for class 9 students, right? They are not familiar or they are not clear with mole concept. So let's start. So let us try to understand this simple equation. That means that here two hydrogen combines with oxygen to form water, right? So from this equation you can see that here two molecules of hydrogen combines with one molecules of oxygen to form two molecules of water, right? So it's too simple, right? And this equation is also a balanced equation, right? So what is atomic mass of hydrogen? That is 1U. What is atomic mass of oxygen? That is 16, but here two oxygen atoms are present, so 2 into 16, that is nothing but 32U, right? So I will substitute this atomic mass in the above equation. That is 2 hydrogen when combines with oxygen, it will give you 2 times of water, right? So for this equation we will try to substitute atomic mass, that is 2 into 2U plus 2 into 16U, that is atomic mass of oxygen, gives you 2 into 2 plus 16, because 2 for hydrogen and 16 for oxygen, right? Then we will calculate its reactant as well as product part. So in reactant parts you can see that you will get 4U plus 32U, and in product side you will get 2 into 18U. So on both sides you will get same value, that is 36U. So here I can say that 2 law is easily obeyed, that is law of constant proportion, and law of conservation of mass. I can say that these two laws is easily obeyed by this chemical equation, right? So now Avogadro has given one concept. He told that the number of atoms, molecules in any substance is equal to Avogadro number, right? He indicates it as N0. He has given symbol as N0 and its value is 6.022 into 10 to the power 23. So what Avogadro has proposed, that any number of particles or atoms or molecules in any of the substance is equal to its magic constant or Avogadro number, that is 6.022 into 10 raised to 23, right? So let us try to understand it with example, that if there is one atom of hydrogen, there is only one atom of hydrogen, then what will be its atomic mass? That is nothing but 1U, which is equal to 6.022 into 10 raised to 23, right? Let's take there is one atom of oxygen. It is also nothing but equal to, what is atomic mass of oxygen? 16U, which will be equal to 6.022 into 10 raised to 23. Let us take there is one molecule of water. What will be its atomic mass? It is nothing but 18U, that we have already found, that is 18U, which is also equal to same, that is 6.022 to 10 raised to 23. So I think now you must be familiar that what each atom is equal to, right? I can also write that 1 gram of hydrogen is equal to same 1 gram of oxygen is also same as Avogadro number, and also 1 gram of H2O also consists same Avogadro number. So I think now you have understood that what is mole, right? Now there are certain formulas to find number of moles. We will discuss it right now. So formula to find number of moles. So first formula with respect to mass is number of moles, that is small n, will be equal to given mass, that is small m, divided by your molar mass, it is actual mass of a given substance. Okay, it is given you as a capital M. And second, with respect to particles, same number of moles, small n, is nothing but equal to given number of particles, that is capital N, divided by your Avogadro number. Avogadro number, that is N0, right? What is Avogadro number N0? N0 is nothing but 6.022 into 10 raised to 23, which was given by a famous chemist, that is Avogadro number, right? So from these two formula you can also find given mass or given number of particles, right? We will try to solve the numericals based on this mole concept. Okay, so here one numerical is given, that calculate mass of the following. First question is 0.5 moles of nitrogen gas, second is 0.5 moles of nitrogen atoms. Third question and fourth question is based on particle, that is 3.011 into 10 raised to 23 number of n atoms are given. You have to find the mass for the same. In same way 6.022 into 10 raised to 23 number of nitrogen atom is given, and you have to also calculate the mass for the same, right? So let us start answering all of this. So let's solve first, that is 0.5 mole of nitrogen gas. As you all know that molar mass, which is given as capital M, for nitrogen will be 2 into nitrogen atom. As you all know, the atomic mass of nitrogen is 14 atomic unit, and 2 into 14 is 28 U. So we'll use one formula, small n equal to m upon m. This is nothing but your given mass, and denominator is given as molar mass. Okay, so therefore to find mass there will be n into m. N here given as 0.5 mole. It is already mentioned in your question that n is nothing but 0.5 moles. Okay, so 0.5 into molar mass, that is 28, that is 1 by 2 into 28. Answer will be 14 U. Any doubt? Okay, I think this concept will be clear. Okay, now 0.5 moles of n atoms. So for 0.5 moles of n atoms, we have to consider molar mass of only one nitrogen atom. This is main thing. You have to consider only one n atom. So one n atom means 14U. We will apply this formula directly. That is m is equal to n into n. Here n is 0.5 into 14. That is nothing but 7U. See, it is a bit logical, as here molar mass is given as 28. It is of 2 nitrogen. If we think logically that if we take half a mole of nitrogen gas, then what will be its atomic mass unit? 14U. If we directly logically calculate what will be half the mole of nitrogen atom, it will be 7U. So answer is 7U, right? Now let us work on particle. So here the number of particle n, capital N, is given as 3.011 into 10 raised to 23. So here first step is to find number of mole, as number of mole is not given over here. So there is one formula, that is number of mole n is equal to given number of particle divided by Avogadro number. So when you will substitute Avogadro number and given number of particle, then you will get answer as 1 by 2. So n is nothing but 0.5 moles, right? So here n is equal to 0.5 mole. So if you want to find mass, then you will use n equal to small m by capital M. Therefore small m is nothing but n into m, that is half into m is molar mass of n atom. Molar mass of n atom is 14, so it will be nothing but 7u. 7u means here u indicates unified mass. Okay, u is nothing but unified mass. So in this way you can also calculate for fourth, that is 6.022 into 10 raised to 23 number of nitrogen atom is given, then how much mass of N2 atom will be present over there. Okay, so let's do it. So if there is 6.022 into 10 raised to 23 atoms of nitrogen atom, then what will be your given mass? So first we will use number of mole equal to n upon n0. N is given number of particle, n0 is Avogadro number, right? So here given number of particle in the question is 6.022 into 10 raised to 23, which is also same as Avogadro number, which will cancel out and we will get only 1 mole, right? Now we will use second formula for calculating given mass. What is formula? That is number of mole equal to given mass upon molar mass. So molar mass is nothing but a multiplication of number of mole and your molar mass. So number of mole here we obtain is 1 moles and molar mass is 14. So 14 multiplied by 1, answer will be 14u. So in this way you can calculate the numericals which is given in your textbook as an example. You must be familiar with mole concept, you must be familiar with atomic mass units, because it will be repeated in 11th science in first chapter. Okay, I am again repeating, the number of particles, atoms of any substance is nothing but equal to one magical constant. You can say it as a Avogadro number, and Avogadro number is nothing but 6.022 into 10 raised to 23. Okay students, thank you.